For decades, astronomers thought they understood galaxy sizes. There were limits, physical constraints, rules that couldn't be broken. Then, in 2022, they found something that shattered everything. Alcyoneus, a galaxy 16 million light-years across, 100 times wider than the Milky Way. It shouldn't exist. According to every model, galaxies don't grow that large. Can't grow that large. But there it was, hiding in plain sight, waiting for someone to look the right way. This is the story of the first galaxy that broke the size ceiling. For over a century, astronomers measured galaxies the same way. Point a telescope, count the stars, measure the light, draw a boundary where the stars fade out. Simple, reliable, completely wrong. This method worked for normal galaxies, spirals, ellipticals, the Milky Way, Andromeda. Measure the stellar disk. You've measured the galaxy, but it missed something massive: radio emission, beyond visible light, beyond what optical telescopes could see. Entire structures are invisible to traditional astronomy. Giant radio galaxies had been spotted before. Centaurus, A, Cygnus. A, massive lobes of radio emission extending beyond their visible boundaries. But even those seem to follow rules. A few 100,000 light-years, maybe a million. Large, but not absurd. Astronomers assumed that was the limit. The problem? They were looking with the wrong instruments, at the wrong frequencies, in the wrong way. Then LOFAR changed everything. Low Frequency Array. A network of 20,000 radio antennas is spread across Europe, designed to detect the faintest radio whispers from the universe. February 2022. Astronomer Martijn Oe at Leiden Observatory is reprocessing LOFAR data, looking for missed signals, patterns buried in noise. He finds something impossible: 2 massive lobes, radio emission stretching across the sky, connected to a single, unremarkable galaxy. He measures, checks, measures again. 5 megaparsecs, 16 million light-years from end to end. Nothing that large should exist. The galaxy itself is ordinary, elliptical, about 240 billion solar masses, sitting 3 billion light-years away in the constellation Lynx. Its central black hole? 400 million solar masses. Not particularly large. Radio power? Normal. Star formation? Barely happening. Almost dead. By every conventional measure, this galaxy is average. Forgettable. Except for one thing. Its radio lobes stretch 16 million light-years into space. That's not supposed to happen. Giant radio galaxies typically have massive black holes, enormous stellar populations, extreme power outputs. This galaxy has none of that. The team runs simulations, checks for errors, verifies everything. Everything checks out. Alcyoneus is real. They named it after the king of the giants in Greek mythology. A fitting name for something that broke the rules. Compare it to what came before. IC 1101, the previous largest known galaxy, 6 million light-years across. Alcyoneus is nearly 3 times larger. 100 Milky Way galaxies laid end-to-end wouldn't match its length. The entire local group of galaxies spans about 10 million light-years. Alcyoneus is bigger than that. This wasn't just a new record. It was a paradigm shift. The size ceiling was an illusion. Once the shock faded, one question dominated everything. How? How does a completely ordinary galaxy create something so extraordinary? The answer lies in what astronomers couldn't see: the space between galaxies. Alcyoneus sits in a filament, a thread of galaxies and gas connecting massive galaxy clusters. Most of the universe's matter lives in these filaments, invisible, ignored, critical. The galaxy also occupies a low-density region, less resistance, less matter pushing back. Think of it like this. Blow a bubble in thick syrup. It stays small. Blow a bubble in thin air. It grows easily. Alcyoneus is blowing bubbles in cosmic air. So it wasn't the galaxy, it was the space around it. The intergalactic medium around Alcyoneus is unusually thin. The jets meet less opposition, travel farther, expand more. But there's more. The lobes aren't just expanding randomly. They're following the cosmic web, guided by invisible structures. Filaments channel the jets, shape them, allow unprecedented growth. For hundreds of millions of years, the jets kept running, pushing plasma farther and farther, never encountering enough resistance to stop. This realization changed everything. Size wasn't about the galaxy itself. It was about the environment, location, the invisible medium shaping structures we can barely detect. Alcyoneus proved galaxies could grow far larger than models predicted. Not through extreme power, through time and favorable conditions. Let's break down the machinery. At the center sits a supermassive black hole. 400 million solar masses, actively feeding. Matter spirals inward, forms an accretion disk. Friction heats the gas to millions of degrees. The disk blazes, but not everything falls in. Magnetic fields thread through the disk, powerful, twisted. They channel some of the infalling matter, redirect it, funnel it toward the black hole's poles. Two jets erupt, perpendicular to the disk, moving at nearly the speed of light, beams of plasma shooting into space. These aren't gentle streams, they're cosmic blowtorches, punching through the galaxy, exiting into intergalactic space. The jets keep going for millions of light years, for millions of years, continuously fed. Eventually, the plasma slows, the jets terminate. The material spreads out, forms massive lobes. These lobes emit synchrotron radiation, electrons spiraling in magnetic fields, generating radio waves, the signature glow that LOFAR detected. The process is violent yet delicate. The jets must maintain coherence over millions of light years. The black hole must keep feeding long enough to sustain everything. For Alcyoneus, this process ran for an inconceivable time. The lobes contain plasma ejected hundreds of millions of years ago, still glowing, still expanding. And here's what matters. Those lobes are messengers, revealing the structure of supposedly empty space, mapping the intergalactic medium, showing us the invisible cosmic web. Alcyoneus isn't just big, it's a probe, measuring what we can't otherwise detect. Once scientists knew where to look, they began finding more, thousands more. LOFAR surveys revealed over 8,000 giant radio galaxies, most spanning millions of light years, all previously missed. They were always there, hidden in the data, invisible to instruments that couldn't detect faint, extended structures. Alcyoneus was the breakthrough, the galaxy that forced astronomers to look differently, to question assumptions, to realize the universe was far stranger than their models allowed. It proved that the size ceiling was artificial, a limitation of observation, not physics. Now we know. Giant radio galaxies aren't rare anomalies. They're common, scattered throughout the universe. The question isn't, how did one galaxy grow so large? It's, how many others are out there? Here's what shatters perspective. Alcyoneus spans 16 million light-years. We're seeing it as it was 3 billion years ago. What does it look like now? We don't know. We can't know. Not for another 3 billion years. The jets might still be running, pushing the lobes farther, or they might have shut off. The black hole starved. The lobes are fading. Another galaxy might have collided with it, merged, disrupted everything. We're looking at a fossil, a snapshot frozen in time. And here's the deeper realization. The lobes aren't just radio emission, they're material, heavy elements, iron, oxygen, carbon, created in stars, scattered by the jets across millions of light years. Those elements mix with intergalactic gas, seed new galaxies, new stars, new planets. The iron in your blood came from stars, transported by jets like these, spread by galaxies we're only now discovering. You're connected to Alcyoneus, made from the debris of giants, assembled billions of years later into something capable of understanding them. Alcyoneus, the first galaxy that broke the size ceiling. It forced astronomers to rethink measurement, to look beyond visible light, to question assumptions held for a century. Once we knew where to look, thousands more appeared. Giants hiding in plain sight, revealing structures we didn't know existed. The cosmic web, the intergalactic medium, the invisible architecture of the universe, written in radio light. Alcyoneus changed everything, not by being the biggest forever, by being the first to break our mental model. Subscribe for more cosmic discoveries. Drop a comment on what assumption about the universe you most want to see shattered. The universe has no ceiling. We're only beginning to understand how far it can go.